An exponent is a number written in this way. So here we have two numbers, but this is a symbol for one number. So it's called an exponent. It is a raised to the power of n. And per definition that means a multiplied by itself n times. For example, 2 to the raised to the power of 3 is 2 multiplied by itself 3 times. So this is 8. Then we can write down several rules for manipulating exponents. For example, if we have a to the raised to the power of m multiplied by a to the raised power of n, we have that we can write this as m plus n in the exponent. And this we can show if m and n are integers, or at least natural numbers. We can show it in the following way. So this is our first rule. So a to the raised to the power m, a to the raised to the power n. This means a multiplied by itself m times. And this means a multiplied by itself n times. Then we see in total how many a's do we have. Yeah, we have m plus n. So this can be written a to the m plus n. And this is just this rule of computation. For example, if we have 2 to the raised to the power of 3 multiplied by 2 to the raised to the power of 4. This is 2 to the raised to the power of 3 plus 4. So this is 2 raised to the power of 7. Notice that if we would have written like this, for example like this, we couldn't have used this rule because we don't have the same number in the base here. So it must be same number down. Another rule is this one, a to the raised to the power of m, then this exponent raised to the power of n. Then the rule says that this is m multiplied by n. So why is this? Yeah, if we have a to the raised to the power m raised to the power of n, this is a raised to the power of m multiplied by itself. N times, per definition. But then we just see this represents a multiplied by itself m times, and all of these do the same. So how many a's do we have in total? Yeah, we have m plus m plus m n times. So this is just m multiplied by n. So this is how many a's we have here. And that's just this rule here. So for example, 2 to raise to the power of 3 raised to the power of 4. So this is 2. Then the rule says that we can just multiply. So this is 2 raised to the power of 12. And this we can of course calculate what it is. So how do we do that? Yes, it's just take 2 multiplied by itself 12 times. So 2 times 2 times 2. So if you do that, we end up at 4096. Another rule for exponents is this. So if you have a multiplied by b, and this product raised to the power of n, the rule says that you can do like this, a to the raised to the power of n, b raised to the power of n. So how can you show that this rule holds? Yeah, just use the definition again. So this means a multiplied by b n times. So we have n of these pairs. So how many a's do we have? Yeah, well, of course we have n. So this is a raised to the power n. How many b? Yeah, also n. And this is just this rule here. So for example, 2 multiplied by 3 raised to the power of 4. So this is 2 to the raised to the power of 4 times 3 raised to the power of 4. And this is 2 times 2 times 4 times, so this is 16. And this is 3 times 3 times 3 4 times, so this is 81. And calculating this will be 1296, doing with calculator or doing an algorithm or some mental computation. Then we also have a rule for dividing two exponents. So you have a to the power n, m, and a raised to the power n. So then you have a rule for this is a raised to the power m minus n. So why does this rule hold? It holds because if you write the left hand side, here means we have a multiplied by itself m times. And here we have a multiplied by itself n times. So this is fraction. So if we simplify this fraction pairwise, shortening them out, then we'll see how many we will end up with. Yeah, if m is larger than n, then we just remove n of these from n. We will remain this many. And if this number is less than this one, then the remaining here will end up here. So let's take an example of the last situation to see what it would mean. So we take a to the raised to the power 2 and a raised to the power 3. So this is a times a. This is a times a times a. So if we shorten out here, we'll end up with 1 over a. Okay, so on this left hand side, if we want this rule also to hold when the number below is larger than the number up, then this should equal to 2 minus 3, according to this rule here. Okay, so what is a up to 2 minus 3 is minus 1. So here we say a up to minus 1, then we need to define like this. So a to the minus 1 is 1 over a. So if you define a to raise to the power minus 1 as this, then we can use this rule also when m is smaller than n. So defining negative exponents in this way makes the formulas or rules work also for negative exponents. And that means, for example, just take one of the rules we have already gone through, for example this one. If we define a up to minus 1 as this, then these rules will also work if m and n are negative numbers. Then we will still have rules working like this. So if you define in this way. And further, if we define, for example, a to the raised to the power of n, then we define this as a raised to the power of n. So 1 over a raised to the power of n. So we also define like this. Since that is also in line with all the other rules, make them consistent. So this is a definition we make here, because then all the other rules will work also for exponents that are negative. Another rule we have is if you have a divided by b and then raise this to the power of n, then the rule says that this is a raised to the power of n, b raised to the power of n. And this we also can show, since this is a, b multiplied by itself n times per definition. But then we use just the rule for multiplication of fractions. We can multiply the numerator and we get n of them, n a's. And we multiply the denominators, we also get n b's. So here we have n, and here we have also n. So this we can write as a to the raised to the power n, b raised to the power of n. And then we get just this rule here. For example, 2/3 raised to the power of 4. This is 2 raised to the power of 4. 3 raised to the power of 4. So 1681. So far we have made a lot of rules of exponents. We have made them work for all integer exponents. So integer can be positive or negative. So that, for example, if we have 10 raised to the power minus 2, what does that mean, by the way? It's 10 minus 2. This is per definition 1 over 10 to the power of 2. So this is 1/100th. 10 times 10 is 100. So this means 100. So if you multiply this by 10 raised to the power of 3, and this is of course is 1000, then we can use the rule we have already seen. We can, since we have the same base, we can add exponents. Since we can use all the rules both if there are negatives and positive integers here. Then we have minus 2 plus 3. So this is 10 to the 1. And 10 to the 1 is just taking 10 one time. So this is 10. Or taking another example. 5 raised to the minus 2. What's that? 5 raised to the minus 2. That's per definition 1 over 5 squared. So this is 1/25. And if we raise that to the power of minus 3, then we can use the rule, one of the rules we have gone through. See that then we can multiply the exponents. This works now also for negative exponents. So minus 2 times minus 3, that's 6 plus 6. So this is 5 raised to the power of 6. And using, for example, a calculator, this is equal to 15,625. What would be, for example, if we take 2 raised to the power of 0? What would that be equal to? Yeah, if you want all the rules to work as so far as you have seen, then it needs to be equal to 1. But we can show it in the following way. So let's take, for example, 3 here. And then minus 3 here. So what's this equal to? This is 2 to the third, and per definition this means 1 over 2 to the third. And we see that this must equal to 1. So on the one hand this must equal to 1. On the other hand, we can use this rule since they have the same base that we can add the exponents. So this must be 3 plus minus 3, or 3 minus 3. So this is equal to 2 raised to the power of 0. So here we see that 2 raised to the power of 0 must be equal to 1. So if we want this to be consistent with the rules, then we need to define this as 1. So then we have, for example, 2 raised to the power of 1 is 2. 2 raised to the power of 0 is 1. 2 raised to the power of minus 1, that's 1 over 2 raised to the power of 1. But that's just 1 divided by 2, so this is a half. After we have talked about roots, in the next video we will come back to exponents again, when we have exponents with any number in exponents. Now we have seen what to do if we have an integer, but one can define it also for other types of numbers, rational numbers and real numbers. but that we'll come back to after we have talked about roots.